It's another Dr. Ben update. Let's go. Okay, this is about another new preprint on bioRxiv that I found interesting. So its title, is ACE2 expression in human dorsal root ganglion sensory neurons, implications for SARS-CoV-2 virus-induced neurological effects. Oh my gosh, yeah. And so the gist of the paper is that the dorsal root ganglia are so along your spine. There are these little points where nerves are going to branch off, and it's going to be at the back of your spine. And right where a bundle of nerves is branching off, all of the nerve cell bodies are going to be in a blob right there. So it's kind of at the edge of your spinal cord. Think of it that way. And so the neurons in this area are going to be nicely wrapped up. They'll have a lot of supporting cells around them and insulating cells so that they don't, get electrical signals basically jumping from one to the other. They're nicely shielded wires. And what this shows is that there is a lot of ACE2 receptor, which is at least one of the proteins that you definitely need to get the coronavirus into a cell, and seems to be the main one. It seems like if you don't have Tempress 2, you'll have cathepsin L, and if you don't have cathepsin L, you'll probably have Tempress 4, and there may be other proteins out there that are able to do the second job, but it looks like it's got to be ACE2 doing the first job at the moment. So, and this is the point of the paper. This is it in a nutshell, that those cells, there's a nice little graph in there where those cells are bright green because they've been staining for ACE2. And all the cells around them are just, like they're not even there because they don't have ACE2. So they're saying that this could be the root of some of the effects on the nervous system that we're seeing. So we've been looking at potentially, could it be the brain that's doing this? But there are these dorsal root ganglia, and there are lots of them. Everywhere that there's a branch point, there will be neurons, and there will be ganglia, and there will be ACE2. And so these are what all of the nerves in, for example, your legs and, just like the bottom half of your body are going to connect up to here. And so the idea is that, at least some of these nerves may be hit with the virus in some way. Now, we don't have a good mechanism for how these nerves could get actually infected. There doesn't seem to be really any good evidence that the virus is in the bloodstream. And even if it was in the bloodstream, I don't know how it would get to a nerve. The nerves are going to be hooked up to things like muscles. There's no real evidence that muscles are infected, although there is blood in muscles, so potentially, maybe, but I don't know. It is a conundrum. It's one to add to the list of things that could happen, but we're not sure if they do happen. But they might happen in some cases and not others, and they might help explain some things that people feel in there. And so that's interesting science, potentially. But I'm just not sure. I'm not sure what to do with it yet. So it's a little thing you file away in your little filing cabinet of potential COVID facts. And when something comes up and they find out that, all of a sudden dorsal root nerves and their ganglia are super critical to the progression of COVID, then you can say, oh yeah, I remember hearing that, and I remember why that works. So we've got the why, we just don't have the whether yet. So I don't know. Maybe that'll come, maybe it won't, but that's what science does. We try and get ready for a lot of possibilities and, be able to figure out how things work. So that's a good case of that. Thanks very much. This is a Dr. Ben update.